Alright, you're welcome to today's class, and we'll continue our work from where we stopped previously. And today we're looking at solid measuration, how we can find the area and the volume of solid shapes. Solid shapes are also known as three-dimensional shapes. We have majorly two types of shapes. We have two-dimensional, those that have only a base and height, that's length and breadth, or base and height. Two-dimensional shapes, and those shapes can be represented on a plane surface. But we have other objects, which are the real objects in nature, we call three-dimensional shapes. And three-dimensional shapes basically have length, it has width, and it has height. So it becomes three-dimensional. And in that, the first shape we'll be looking at today is a cube. When we speak about a cube, we are talking about a three-dimensional shape that has three faces of equal magnitude. So if you find a cube, can we count the number of faces? 1, 2, 3, 4, 5, 6. That is this one, 1, 2. There are 6 faces, and it has how many vertices? Vertices are the edges here. How many vertices? 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8. It has 8 vertices. And how many edges? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There are 12 edges in a cube. Same thing in a cube. So the first shape, like I said, we'll look at is a cube. When we are looking for the surface area, we have a structure called a cube. Finding the surface area of the cube, we are referring to the total area occupied in space by the entire surface. For instance, if I place a piece of book on a table, the area of that book is the space the book occupies on that table. Same thing if I have a cube, like a cube of sugar. That's an example of a cube. If I place it somewhere, maybe to make it clearer, if I place it inside a glass or inside water, okay, you will find out that there is an area, there is a portion that cube is occupying in space. That's what we mean by the word surface area. And the area of the surface, since all sides are equal, it is what? 6 times what? The area of one side. And what would that be equal to? That would be what? 6. In the area of one side, since this is x, every side must be what? X. To make it easier for us, we call a side what? X. So it will be what? 6x squared as area. The next thing we'll look at is the diagonal length. The length of diagonal, that is from one point here to the other point. Diagonal. A line that crosses from one vertex to the opposite vertex. Now, if you want to find the diagonal, it is simply what? X root what? 3. X root what? 3. Basically, the diagonal is supposed to be x squared plus what? X squared plus x squared. Square root of everything all together. Since we are dealing with the length of the 3 parts. But since all sides are equal, then we can have what? S squared plus S squared plus S squared will give us what? 3s squared. So square root of 3s squared will give us what? Root S squared is what? X. Root 3 is what? 3. So it will give us S root 3. Then the next thing we look at is the volume of the cube. The volume of a cube is always measured as what? The volume means the amount of space that is occupied within that solid shape. For instance, if I place water inside this cube, the volume of the cube is the what? Amount of water that will fill up that particular cube. For a cube of this nature, the volume of this cube will be what? X raised to power 3, because we will deal with what? All the sides. Since all the sides are given on to us, and volume is measured in meter cube or centimeter cube, it will be what? X times what? X, which is equal to x raised to the power of what? 3. That's simply the volume occupied. It's like saying the volume is like saying area times height. Do you understand? That's area times height. next shape we'll look at today is the shape that is called a cuboid. A cuboid is a three-dimensional solid rectangular shape. It's like a rectangular block. And if you observe a cuboid, you find out that it also has what? 6 sides. The only difference is that all 6 sides are not equal. Rather, 2 of the opposite sides are equal. It has 6 sides. 2 of the opposite sides are equal. So we have 2, 1 to group them. And it has how many vertices? Still has 8 vertices and what? 12 edges. When we measure the surface area, if we say and this is what we call the what? This is the length. Do you understand? This is the width. Okay, and this is the height for a shape like this. So if the width is x, the length is y, and the height is z, then we measure what? xy, meaning if this is, we have what? This is x, this must be what? X. So we have xy, and there are 2 of these. Both are at the top and at the bottom, so we have 2xy. We also have what? xz. That is, xz is the width, because this will still give us z, right? The height times the what? Width. So we have what? xz. And there are 2 of them at the opposite side. You also have what? yz, which is what? This box, and there are 2 of them. So we have 2 times xy plus 2 times xz plus what? 2 times what? yz. And it will give us what? 2 times xy plus xz plus what? yz. The next thing we'll look at is the length of the diagonal. The length of what? The diagonal. In a given shape like this, we come to find out that the diagonal is the length that crosses from this part to this part. For us to measure that given diagonal, certainly we are going to have what? S squared plus what? Y squared plus Z squared, and square root of everything. So that will give us root what? S squared plus Y squared plus Z squared. The volume is what? Since the length is different from the what? The length is different from the width and it's different from the height. So the volume becomes what? Length times what? Width times height. That's x, y, z. The next shape we'll look at today, number 3, is what we call a cylinder. A cylinder is a kind of prism that has a circular base. And because it has a circular base, if you observe the cylinder, how many surfaces does it have? It has 1 circular surface and 2 what? 1 curved surface and 2 circular surfaces at the top and at the bottom. That's how many surfaces? 3 faces. It has 3 faces, and if you check the number of vertices that it has here, you find out that the vertices are the sharp edge. You find out that there is no vertex. And when you observe the number of edges, how many edges are there? You observe, we have edges. We have 1 and we have what? 2 edges. And we want to look for the curved surface area of a cylinder. We have the base circumference. This is the base circumference times the what? Height. Because we're looking for the curved surface, so we must have the circumference of the entire base times the height. So it will give us the area of the curved surface. Then the total surface area is the area of all faces, and it's in 2 different intricacies. The first intricacy is when both surfaces are closed. When they are closed, it means that we have what? 2 area here. You know, we have the area of the 2 circular surfaces, meaning 2 times pi r squared. Do you understand that? The area of the 2 surfaces, the 2 circular surfaces, that's 2 times pi r squared. Then we have what? The next thing we look at is what? The area of the curved surface. And the curved surface is given to us as what? 2 pi r squared. Do you understand? That's the area of the curved surface. 2 pi r squared. The base circumference is pi, so the curved surface we already have as what? 2 pi r squared. So we add it. When we remove 2 pi r to make it easier for our calculation, we have 2 pi r times what? R plus h. Then the second intricacy is when one top is open and the other is closed. In that case, we only have one circular top. The other is out. So what we have there is what? 2. We have pi r squared instead of 2 pi r squared. What we have below is what? Pi r squared. Do you understand? And plus what? 2 pi r. Now from this equation, we can remove pi r, right? When we remove pi r from here, we're left with what? R plus 2h. That becomes the area of the cylinder when one surface is open. While the volume of the cylinder is what? Base area. What's the base area? Pi r squared times the what? Height. So we have pi r squared h. Let's take some examples to better buttress the points we have here. Let's take some examples. Let's take some examples. The first question we have here, it says a cube has length of what? 5 centimeters. Calculate the surface area, the length of the diagonal, and the volume. So the first thing we're asked to calculate, the first calculation we're asked to do is what? For number one, Roman figure 1, we're asked to calculate what? Surface area. And the surface area, we said that the surface area of a cube is equal to what? 6 times the what? Area. That is 6x squared. Do you understand? So that's 6 times what? What's the length of one side? 5 squared, which is what? 25 times 6. And that will give us 6 times 5 is what? 30. 0 carry what? 3. 6 times 2 is what? 12. Plus 3, that gives us what? 150 what? Centimeters squared. First question. Now the second question, we are told to find the length of the diagonal. Length of the diagonal. The length of the diagonal, we said is equal to what? X root what? 3, right? X is what? 5. So the answer is what? 5 root 3 centimeters. The third thing we're asked to find is what? Calculate the volume. The volume of the cube is equal to what? X cube, which is what? 5 squared 3, which is equal to what? 125 centimeter what? Cube by calculation. Alright? Are we clear on this calculation? Are you clear on this? The next question, which is question 2, we are asked the same question here. It says a cuboid has length of what? 13 centimeters. The width is 9 centimeters. And the height is what? 8 centimeters. We are asked to calculate first the surface area. So the first thing we look at here is the surface area of the cuboid. And we say that the surface area is equal to what? 2 times what? Xy plus what? SZ plus what? YZ. And from this we know that X is what? The width. And the width is what? 9, right? Y is what? Y is the, no, not the height. Y is the length. Okay. So we have what? 13 plus what? 9 times what? The height is what? 8 plus what? 8 times what? 13. That is Y, which is Y is 13 and Z is 8. So 8 times 13. Do you understand? Or by if we write it in order, 13 times 8 is the same thing. So what would that give us? 2 times what? Let me have a calculator. So that will give us 9 times 13 plus 9 times 8 plus 13 times 8 times 2, which is equal to what? Everything will give us 586 centimeters squared. Now the next thing we are told to calculate here, in this question, we have to find what? The length of a diagonal. The length of a diagonal, Roman figure 2. The length of a diagonal. Length of what? A diagonal. And we said that the length of a diagonal is equal to what? Square root of what? X squared plus Y squared plus Z squared. That will give us square root of what? That's what? 9 squared plus 8 squared plus 13 squared